Alright, hello and welcome to another video of the MSU Denver video walkthrough of the Elementary Acupuncture Study Guide. In this video we're going to be talking about systems of linear equations, and in general systems of linear equations you can have multiple equations, 3 or 4 or 5 equations and more than 2 variables, more than 2 unknowns, but for this study guide, for this test, we're really going to be talking about 2 equations and 2 unknowns. If you take algebra, or as you go further, you might see 3 equations and 3 unknowns, x, y, and z. And then if you get into linear algebra, you go into a whole nother level with this stuff. And this is, again, like I said, linear equations. You can also, if we talk about, well, let's first talk about what they're really kind of asking us, right? Well, 2 equations and 2 unknowns, talking about linear equations. A linear equation, right, if I graph it, and let's, I have like the x and the y-axis. This isn't going to be super nice. I'm not an artist. But if I have a line that looks like that, and then that's one of my equations, and my other equations is maybe like that. What they're asking us is they're basically saying, hey, where does this intersect, right? And so I go through the process, and we'll talk about what that is. But to find, these coordinates, and this is, whatever x comma y coordinate that happens to be. But really, if it weren't linear equations, right, just so you can kind of carry this on further, I could say, well, what if I have, this line, I give an equation for this line, it looks really funky, like x, whatever, I'm not even going to go into that, but, and then maybe I give you, a straight line that looks like that, and I say, hey, where do they intersect, right? You could use the same process, right, the process that we're going to do, and there's multiple ways to do this, but we're going to be using the substitution method. There's the elimination method, and you can make matrices to find it that way, but we're going to be doing substitution method. And so if we have 2 equations and 2 unknowns, then essentially what you're going to end up doing is, the first thing you're going to do is well, the first thing I do is, as I kind of, because sometimes in some of these examples we'll see that you're going to have like fractions and stuff, so I try to get rid of any fractions I have if it makes sense to, and we'll talk about that. But after that, you want to solve one equation for one of your unknowns. So whether, get one equation in the form y equals, whatever, or even x equals whatever, whatever one's easier to get. And sometimes they'll give you, like the 2 equations that they'll give you, one will already be in the y equals form, and great, so step 1's done, right? And if it's not, you do that step. And then what you do is you're going to, and I'm going to talk about this, but it's a lot easier to kind of see it as we go, and so I'll do an example here in a second, but you're going to take what you get, the y equals, and you're going to plug it into your other equation. And then when you do that, you'll find that you have one equation with one unknown. And the rules go that if you have one equation with one unknown, like even just like 5x plus 2y, 5x plus 3 equals 6, you can solve for x, for a number, right? Maybe it's going to be a fraction, but you can solve it for a number if I just have an x in one equation. And then if I have one equation with 2 unknowns, right, I can't get a number, right? That's something that's a linear equation, right? So I'll have y equals 5x plus 2 or something, right? I can't get y equals some number because they both changed. But if I have 2 equations and 2 unknowns, then I can get numbers for both those, and it goes on like that. But that's the one we're going to care about. We have 2 equations and 2 unknowns, so we know that eventually we can solve them for numbers, because assuming that they're not parallel lines or the same line, because then there'll be infinite numbers. But if they just intersect once, if they're straight lines, they can only intersect once, and so you'll get an answer, assuming again that they're not parallel. But the reason I say that is that when you plug it into the second equation, when you solve for one equation, you plug it into the second equation, then you only have one equation with one unknown, and you can solve for a number. Once you get that, so let's here. Let me write this down. Solve one equation for x or y, and this is assuming our variables are x or y, which they all are in all of these examples. But it could be g and t, but whatever. But you're going to solve for one of the variables, x, y, and z. If you have 3 variables and 3 equations, you can solve for z. And then step 2 is you're going to plug it into the second equation, and it doesn't have to be like the left equation or the first one they give you. Either one's the first equation, whatever one's easier. You plug that into the other equation. So plug. I'm not going to say plug into. I'll say the second, right? But the other equation, because I called the first one the first equation, the one equation. And then solve for the unknown. And again, at this point it could be x or y, but whichever one it is, you're only going to have one of them. And so just solve for whatever one it is. Solve for the unknown. I should put a 4 in there. And then the last step is you plug that unknown, and this always isn't going to be these steps might not be the easiest thing in the world, but they're very, I guess, broad steps, I should say, but they might be easy, they might not, but if you go in order, this should get you to the end, and once you have a number for some unknown, you plug that unknown, so you plug the unknown that you solved for, so I guess that's now known. And this will all make a little bit more sense when we go through an example. And you can plug it into either equation. And again, you want to plug it into the easier equation. You don't have to. You can certainly plug it into the hard one if you want to. It's going to give you the same answer, I guarantee you that. But I would plug it into the easier one just because you're going to get the same answer either way. So you plug it into either equation, and then you'll get your other unknown. So I'll say to get your second, because that's the only one that we, again, for these examples, we only have two unknowns. Your second unknown. All right. Like I said, it's going to be easier once we start doing examples. And so I'm just going to jump straight into, because there's a lot of examples in this. I'm just going to go straight. I usually make my own, but I'm going to jump straight into the practice problems that the study guide gives. And if you're following along, we're on page 22. And for these practice problems, I am going to be doing the even practice problems. And I would just like to note that in particular, they get harder as you go along, but 4 and 8 in particular, we're going to end up with fractions. So it's not the easiest thing in the world, especially since you don't want decimals. You don't get a calculator on this test, so we have to have fractions. So it's not going to be fun, but I'll walk us through those. Those are definitely the two hardest ones in these examples, and so we'll do this together. But they can get that hard. They shouldn't get any harder than 4 or 6. But typically, if you get whole numbers, it's actually not too bad. But let's start walking through. Like I said, I'm going to do the even one, so I'm going to start with number 2. And I'm just going to jump straight into it because, like I said before, it gets a lot easier once I'm walking us through a problem actually, and you're kind of seeing what we're doing. And so number 2, real quick, number 1. If you look at number 1, it already gives us y equals on one of them, so that's great, right? We're set up already. And if it does that, then great, use that. If it doesn't, let me write down number 2. Number 2 is 5y minus 2x equals 10. And I'd like to caution you that make sure you have two, for these types of problems, you're going to have two equations, for this test. When I looked at some of the problems like on the test, it's kind of confusing like where it stops. So just kind of be careful to read, the problems slowly and make sure the equations that you write down are very distinct and correct, right? Because it's very easy to write down the wrong equation, just missing like a negative sign or something like that, or a 6 instead of an 8, and it throws the whole thing off. So you'll have lots of time on the test. Take your time and write down the problems. You should always do this, but write down the problems correctly. So that's one of our equations. The other equation is 3x plus y equals 138. And so neither equation is in the form y equals or x equals, so we're going to have to solve for something. And I am going to take our second equation over here, and I'm going to solve for y, because the first thing I do is I look for, if I don't have an equation in y equals or x equals, I look for, are there any that don't have a coefficient, or the coefficient is 1? Because then I don't have to divide by anything, and I know I won't, I shouldn't get any fractions, or at least, in that first equation, I won't get any fractions. If I don't, like over here, there's a 2 in front of the x, -2, and if I solve for x, I'm going to get, a 2/5 on the y, or -2/5 on the, or I guess 5/2 on the y, -5/2. But if you don't have it, and if it was an even number, then I could divide through, and it's not going to mess anything up, or I'll get whole numbers anyway. But that if there's no coefficient in front of the variable that you're solving for, you're not going to end up with any fractions. I don't like fractions, so I'm going to solve for this one over here. And so the only thing I have to do is I have to just move the 3x over. So I have y equals 138 minus 3x. You could also say that's -3x plus 138. It doesn't really matter in this case because we're not going to be graphing these. But I didn't have to divide by anything, right? So it was I just moved that one thing over, and there you have it, right? I got y equals, and that's step 1. Sometimes both the equations, all your variables have coefficients, and so we'll see that maybe in 4, but probably in 8 too. you end up with these fractions, and it gets not impossible and not really tough, but harder to solve. And so I want to make it as easy as I can. So that's I look for the one that doesn't have the coefficient, or has a coefficient of 1, excuse me. So now that we've done that, step 2 says, if I scroll back up a little bit, step 2 says plug it into the second equation. And so since I solved for, on the left the right equation over here, I'm going to plug what I solved for into the left equation, the other equation, the second equation. And so I rewrite that equation. I write 5, and then instead of y, right, I'm substituting what y equals to. So now instead of y, I'm going to plug that in, right? And so y equals 138 minus 3x. So I have 138 minus 3x. And then I write down the rest of the equation, minus 2x equals 10. And now you'll see that, it doesn't look exactly pretty, but I have one equation and, just x's, right? No x squareds or anything like that, because these are going to be linear equations. But so now I should be able to solve for x equals some number. And let's see if we can do that. So the first thing I'm going to do is I'm going to distribute the 5, and this isn't going to be the funnest thing, 5 times 138. But you're going to have time, so you can write it out. And 5, let me get that. 138, and I have the 5 down here, and you can do it that way. And you end up getting 690. They may or may not give you a calculator. Again, you can't take one in with you. Sometimes a button will appear in the upper right-hand corner where you can click on it. It doesn't pop up with a little sign either saying, hey, you have a calculator this time. So just be mindful of that and kind of check for it, because if it's there, you absolutely use it. But 5 times 138 is 690. So I have 690. I distribute the 5 to the minus 3x, and I get minus 15x minus 2x equals 10. I'm going to simplify a little bit. I get 690 minus 17x equals 10. And then I subtract 690. I get negative 17x equals negative 680. And then I get to divide by negative 17, and I get x equals, and then so 680 divided by negative 17. Again, that's not the funnest thing in the world to do either, but if you do, you can think about 68 divided by 17 itself is just, well, and you got negative, so it's going to be a positive, because negative divided by negative is a positive. 68 divided by 17, that's going to be 4, and then you have the 0, so it's going to be 40. You can do it the long way as well if you want to do that, or they might, like I said, they might give you a calculator, but it's going to be 40. And I like whole numbers like that, but honestly, like if it was a fraction and you couldn't divide, it'd almost be nicer, right? Because you don't have to worry about dividing a whole number like that. But x equals 40. And so now step 4 is, well, we solved for, step 3 says solve for the unknown, and we did that. We got x equals 40. And then we plug that unknown into either equation, right? And so you're always going to have solved for one of the equations already, like y equals or x equals, right? And so I typically plug the unknown that I solved for into that equation because it's already solved for. I already have y equals, right? And so when I write that out, I have y equals 138 minus 3, and then instead of x, I'm going to put in 40. Oops, not 4, 40. And it's already, solved for me, right? Now, you don't have to do that. You can plug it into any equation, in either of the equations. And just note that the y equals 138 minus 3x is the exact same thing that we started for. So we didn't, we can plug it into the form right below it because it's already solved for y. But whether you plug it into the form right below it because it's already solved for y, or the one above it that we originally started with, or the one over here, either way, when you solve for y and you plug in x and you solve for y, you're going to get the same number. And so if I write this out, I get 138, and then minus 3 times 40 is 120. And so y is equal to 18. And so if we were talking about linear lines, right, these equations, if we were to graph them, they would cross at the point 40, comma 18. But typically, like on this test, and for the answer key and stuff like that, for the multiple choice, they want it written out like x equals 40, y equals 18. So that's number 2. Number 4, as you'll see, gets a little fun if you like math. If you don't, you're going to kind of pound your head against the table, but we'll get through it. So number 4. Number 4 says 16y, because, number 8's even better. 16y, number 4, though. 16y minus 12x equals 20. So minus 12x equals 20. And the other equation that they give us, 8y minus 6, 8y minus 6 all over 2x equals 2/3. And again, as I said earlier, there's steps, and then you want to follow those steps. But I don't like fractions. I'm going to get rid of the fraction on the right-hand equation first before I even really think about what equation I want to solve for. So if I cross multiply here, and again, you should be comfortable doing that. If you don't, please kind of study up on that. But this becomes 3 times 8y minus 6, and then equals, and then I have 2 times 2x. I'm going to distribute that 3 through, and I get 24y minus 18 equals, I don't know what happened over there. 2 times 2x is 4x. And now I have that equation, and I have the equation over here, 16y minus 12x equals 20. I can solve for either one. I don't have a particular preference here because none of the variables have a coefficient of 1. So, like I said, and like I warned you before, this isn't going to be, awesome in any case. I'm going to have to divide. This one over here, and again, I think I've done this a few times, and there are easier ones to solve for to kind of make it easier because stuff cancels out later. I don't remember which is which, so I'm just going to go ahead and solve for y on this one over here on our right-hand equation. You might look at it and say, well, if I just divide by 4, I can I'll get a 6y. You can absolutely do that, right? And I actually encourage you to do that because I'll do it one way. If you do it another way, you should always get the same answer, right? So there are usually different paths to get an answer in math, and typically one path is easier. But just looking at a problem, it's not always easy to tell which path that's going to be. And so, but if you can do multiple paths, it's always better to know how to do multiple things, know how to multiple ways to do certain things. And so, I encourage you to kind of do this different ways. Maybe even, another time start with the left-hand equation over here and maybe solve for x or solve for y over there. You should always get the same answer. But I'm going to solve for y on the right-hand equation. So I'm going to add 18. So I get 24y, add 18 to each side, equals 4x plus 18. I divide by 24, I get y is equal 4 over 24. I get x over 6 and plus, and then I can take a 6 out of each of those, and I get 3 over 4. So, and you can call that 1/6 x if you'd like, and you could do that in multiple steps. If we solved for variables in previous videos, so you should be comfortable doing that. But our final equation over here when we solve for y should be y equals x over 6 or some form of that, plus 3/4. If you solve for y, if you solve for x, it would look a little bit different. I'm now going to take this y equals, and I'm going to plug it into my other equation. So I have 16, and instead of y, I'm going to plug in x over 6 plus 3 over 4 in place of my y, minus, and then there's still 12x here, equals 20. And again, that doesn't look pretty, but at least I have one equation and one unknown, one x, right? So, well, multiple x's, but just x. So I should be able to solve this. And so I'm going to distribute my 6 through, and I have 16x over 6, and I can reduce that to 8x over 3. And then if I distribute the 16 to the 3/4, well, 16 is 4 times 4, and those cancel out, so this would just be actually equal to 12, right? Or you can do 16 times 3 is 48. 48 divided by 12. 48 divided by 4 is 12. Minus 12x. However we want to do that, like I said, there's multiple ways. Plus 20. I want to get, now I'm solving for x's, and so I'm going to get all my x's on one side, and so I'm going to move the 12 over first, just the number 12. And so I have 8x over 3 8/3 x minus 12x equals, I subtract 12 and I get equals 8. Now on the left, before I kind of can condense it a little bit, I gotta make it into a single fraction. So I'm going to call this 12x over 1. My common denominator would be 3, so I'm going to say times 3 times 3. And so I get 8x over 3 minus 36x over 3 equals 8. I can combine that now, and I get, I'm going to leave the room on the right over there. I'm going to leave that for when we solve for the y. But I get 8 minus 36 is 28, well, minus 28, x all over 3 equals 8. Now I can get rid of the 3, multiply both sides by 3, and I get I get 24x on the, let's see, negative 28x equals, not 24x, 24. And now I need to divide by negative 28, and I get x equals, and I have 24 over negative 28, and I can reduce that. If I can pull a 6 out of the top, no, not 6, I can pull a 6 out of the top, I can't pull a 6 out of the bottom. I can pull a 4 out of each one of those. So I get, pull a 4 out of the top, I get, and I'm just going to put the negative out in front there, 6, and I pull a 4 at the bottom, so it's 7. So x is equal to negative 6 over 7. Again, not the greatest thing in the world, because I don't like fractions when my final answers are fractions, but it is what it is. And now we got to plug that into either equation. Now I already have y equals up here, and so I'm going to plug it in there, and I'm going to try and solve for, I will solve for y. So I have y equals, and real quick, I'm just going to change this. Instead of x over 6, I'm just going to change that because it'll be easier here, to just like we did in some of the previous videos. That can be changed to 1/6 times x, right? Plus 3/4. And then, so I'm going to rewrite this 1/6, and then instead of x, I'm going to put in, what do I have for x? Negative 6 over 7 plus 3/4. Okay, well this is nice because the negative's there, but I can cancel these 6's out, right? And these become 1's. And so y equals, and so I have a negative 1 on top, negative 1 over, well, and then there's just a 7 because that's 1 times 7, 7 plus 3 over 4. And now it's just, fractions, and they're actually just fractions with numbers, so that should be pretty easy, right? Common denominator, I'm going to say, is I'm just going to multiply them by each other, which actually happens to be these common denominator. So times 4 times 4 times 7 times 7, I get y equals negative 4 over 28 plus 21 over 28. I can say y equals negative 4 plus 21 all over 28. And so y is equal to 17, because 21 minus 4, or negative 4 plus 21, however you want to look at it, positive 17 over positive 28, 17/28. And so y is equal to, I'm not going to rewrite them because they're right here, but x is equal to negative 6/7. Y is equal to 17 over 28. Not the greatest numbers in the world, but certainly not too bad. It was a lot of work compared to number 2, and honestly, we'll probably see that number 6 isn't so bad, but sometimes you have that much work, and you just got to keep plugging along. If you chose to solve, up here for x or y in our left-hand equation, or if you tried to solve for x in our right-hand equation, you should end up getting both of these answers. Again, there's multiple ways to do it, and so your work might not look like my work, but your answers should your x and y answers should look like my x and y's. And that's number 4. Going on to number 6, scroll up a little bit. Number 6. Now, if we look at number 6, and I'll write it out, but there is a fraction in one of them, and so it might not look like the greatest thing in the world at first, but it actually turns out to be not so bad. It's kind of in between number 2 and number 4, as far as difficulty. So let's write this out. We have on our left equation, we have x plus 29. X plus 29. Sorry about that. Let's see here. Equals 6y minus 6y minus 33. Let me draw a little border right here. And then our other equation is 2x minus 3y all over, wait a minute, I gotta make sure I'm keep writing down the same. You want to make sure you write down the problems correctly, as I've stated numerous times, equals 5, because you'll do all this work that's correct, and then you'll get the wrong answer because you wrote it down incorrectly. All right, so we got our 2 equations, and like I said before, I'm not a fan of fractions, so I'm going to get rid of the fraction in the right-hand equation first, because even if you choose to solve for, say, x in the left-hand equation first, you're going to have to get rid of that fraction eventually. And so I'm just going to do it right away. And so then I have, if I multiply both sides by negative 5, I get 2x minus 3y equals negative 25. And so that's our second equation, just kind of rewritten without the fraction. And now I can choose to solve for whatever variable I want to. And again, I look for the variable with a coefficient of 1, which is over here. I have a 1x, and so I'm going to do that. And so I just subtract 29 from each side, and I have x equals 6y, and then I have negative 33 minus 29. I'm subtracting 29 from each side, and I get negative 62. So minus 62. And then, there you have it. Step 1's done, right? So it's always great when you have a coefficient of 1, or even better if they already solve an equation, if it's already x equals or y equals. But sometimes it's not, as we saw before in number 4, and as we'll see again in number 8. But that's what x equals to now. Then I plug it into my second equation, my other equation that I haven't used yet. And so I have 2x, so 2, and then instead of x, I'm going to put 6y minus 62. And again, as you can see, it doesn't matter that you have to, it's not like you have to solve for y first, which I've done in the last few problems. But, if x is easier, then solve for x first, right? And so I'm plugging in x for this one, and I have minus 3y. I'm continuing on with rewriting the equation above, and equals negative 25. And now you'll see that we have one equation, and our one unknown now, it's x, but it's still just one variable. And so I can solve y is equal to some number. And so let's do that. First thing I want to do is distribute the 2 here. So I have 12y minus 62. Excuse me. 62 times 2 is 124. So minus 124 minus 3y is equal to negative 25. 12y minus 3y is 9y minus 124 equals negative 25. Now I got to add 124 to each side, so 9y equals, no, I forgot my y, 9y equals negative 25 plus 124 is going to be positive 99. And then we simply divide each side by 9, and we get y equals 99 divided by 9 is 11. So y equals 11. So as kind of scary as that might have looked at first, it certainly wasn't bad as number 4. Y is equal to 11. And this is probably the difficulty that you're going to see. You definitely want to be comfortable with doing number 4 and doing number 8, as we'll see. But you're not going to have something super easy like maybe number 2 was, or even number 1. But I don't want to say you're not going to have something as hard as number 4 or number 8. But odds are it'll probably be about this difficulty. So don't get too worried about these problems. They shouldn't be too difficult. And if they are, just kind of work through them, and you'll get there. But we have y equals 11. Now I just plug that into either equation. And again, I already have on the left, I already have x equals. So I'm just going to plug it in there. So x equals 6. And instead of y, I'm going to plug in 11 minus 62. 6 times x equals 6 times 11 is 66 minus 62. And so x is equal to 4. And so our answer is x equals 4, y equals 11. All right, that's it. That's the end of that problem. And so it was a little difficult, but not too bad. Let's move on to number 8. So moving on to number 8. Let's see here. It's jumping on me. All right, number 8. Number 8 looks really fun. Let's see here. Let me kind of draw that. Number 8 says we have 2 times, in parentheses, we got a fraction, we got 9 times 5x over 7 equals 3y. And then our other equation is 3 times, and in parentheses, 10 minus 3y, excuse me. 10 minus 3y over 2x. All right, and then equals 1. All right, well, that's not so bad. Equals 1. I like that. Okay, so now we need to work on these equations first. Again, you don't have to. You can just work one side and get, x equals or whatever, but I like to work them both out first. So with these left-hand sides here, I'm going to put this over 1. I'll put this one over 1 as well, just so you can see. If you're comfortable with just, distributing the 2 to the top, that's fine. But if I rewrite this for you, this becomes 2 times 9 minus 5x over, and then 1 times 7 is 7 over 7 equals 3y. And this becomes 3 times 10 minus 3y over 2x, because 1 times 2x is just 2x. Oops, what's going on? So over 2x, and that's just equal to 1 still. If you don't have to do this in steps if you're comfortable with just kind of jumping ahead. But now I'm going to distribute that 2 through that parentheses. Excuse me. So 2 times 9 is 18 minus 2 times 5x, so minus 10x, and then that's over 7 still. Over 7 equals 3y. And I am jumping back and forth between the two equations, so I apologize if that's unsettling to you. But I'm going to distribute this 3 into that parentheses, so I get 30 minus 3 times 3y, so that's minus 9y over 2x equals 1. And I'm going to multiply each side by the denominator to get rid of the fraction. And so I have 18 minus 10x equals 3 times 7y is 21y. And over here I have 30 minus 9y equals 2x times 1 is just 2x. Again, there's always multiple routes, but that's what I do first. I kind of clean up my equations first. Now I want to solve for some variable for either of the variables, whichever one you find easiest. I'm going to solve on the right hand equation over here. I'm going to solve for my x. So I'm just going to divide everything by 2. You can do whatever you want. In the end, we'll get the same. We should get the same answers. If I divide by 2, then 30 divided by 2, that's 15 minus. I'm just going to put this as 9 over 2 y equals x. Oops. All right, so now we have x equals something, and so we're going to plug that into our other equation. So I'm going to rewrite this left-hand equation over here as 18 minus 10. And again, I have x equals 2 in my right-hand equation, so I'm going to replace that x. And so instead of x, I write 15 minus 9 over 2y. And then that all equals 21y. Now I'm going to distribute that negative 10 through, and so I have 18 minus, so I have negative 10 times 15, so that's negative 150, so minus 150, or you could say it's positive, minus the positive, whatever you want, but it's 150, so minus 150. And then I have the negative 10 times the negative, so it's going to be plus. And then if I think about it, it's going to be, I'm just going to, this is 10 over 1. You can think of it as 10 over 1. And then, so that would be positive 90 over 2 times 1 is 2, so 90 over 2, or 45. Or you can say, well, that 10 is 5 times 2, and so the 2's cancel out, and so you have 5 times 9, and that's just 45. Either way you do it, but it's going to be plus 45y equals 21y. Now I'm going to condense this over here. I'm going to simplify it a little bit, and I'm going to have 18 minus 150 is minus 132 plus 45y equals 21y. And if I subtract 45y, you're going to have a negative y. You're going to have to divide by a negative to get just y. Or you can move the 21y over to the left and move the 132 over to the right. It doesn't matter. You'll get the same answer. I'm just going to move the 45y over to the right. So I'm going to minus 45 minus 45. Y, and I get 132 on the left here equals 21 minus 45y. 21 minus 45y is, let's see here, 20. So it'd be a minus 20, 24y. I think that's correct. And then I have to divide by, like I said, the negative 24. Divide by negative 24 to get y by itself. I like to write my variables on the left over here. I don't always do that, but you can do it on either side. And just real quick, I said up here 18. You might have caught this already and be like, what is he doing? 18 minus 150 is negative 132. I didn't carry that negative down, so that should be a negative. That means that's a negative. And so it's going to be the same number, but our answer is going to be positive because negative over negative is a positive. And if you, so it's negative 132 over negative 24, but if I reduce that, I can get 11 over 2. I can pull a 12 out of each one of those. I mean, if you do it in smaller steps, maybe you pull a 6 out of each one first and you pull a 2, but it reduces down to 11 over 2. And you want to do that. I mean, that's going to be your answer. That's going to be what's on the multiple choice, but you want to do that anyway. You want to reduce it as much as you can because now I have to plug this back into my other equation, and if I could plug negative 132 over negative 24 back in, but it's going to make it ridiculous. So I don't want to do that because I don't have a calculator. So I'm kind of lazy. So I want to reduce it. I get 11 over 2. Y equals 11 over 2. Now I got to plug that into their equation. So I'm going to rewrite this equation as, and I'm going to use this one right here because it's already solved for x. 15 minus 9 over 2y. And it's already written as a fraction in front of the y. That's nice because I have another fraction to plug in. 11 over 2 equals x. I have the 15 here, so I'm not going to do anything with that yet. Minus, and then 9 times, I can't, if you can reduce this at all, please do that. But I can't reduce it the way I'm multiplying right now. So it just becomes 99, 9 times 11 is 99, over 4 equals x. And then we just have a couple fractions that we need to get rid of. So this is 15 over 1. Common denominator is 4, and it becomes 60 minus 99 all over the common denominator of 4 equals x. And then x, I'm just going to flip-flop it on you just to kind of confuse you. X equals 60 minus 99 is negative 39 over 4. And that's our answer for x. So 11 over 2, negative 39 over 4, not the prettiest numbers in the world. But again, this could happen, right? They could give you this problem. And so you want to be comfortable doing this. I would definitely try redoing this problem, perhaps solving for a different variable at first, and then therefore getting into different math along the way. But you should come up with the same answers. Because this is a tough problem, and the more you practice tough problems, the better you're going to get. But these are the answers. Y equals 11 halves, and that's one way to do it. I really just solved for the easiest one that I thought was first. The up here, I just said, well, if I divide by 2, that's going to be pretty easy, and I'm going to get some fractions. But try solving for y, or going over to the left-hand equation first and seeing if that works out any differently. I would definitely, though, suggest if we go back up to the top here, kind of working out the equations first until you get something that looks like this, just one line, because it will make it easier on you in the long run to do that first. All right, so we have one more problem in this section, and it's going to look pretty bit of a long video, so I'm going to try to wrap it up pretty quickly. Number 10, it's not going to be too bad. It's not going to be bad as number 8, but let's jump right into it. So number 10, I'm going to scroll up a little bit more. Number 10 says, let's see here. So number 10 says 4 times, and then in parentheses, x plus y all over 7, and that is equal to 2x minus 4y. And be careful, because typically on the right we've been having just the one thing, like 2x or something like that, and now we have 2x minus 4y all on one side of an equation, on the right side of the equation. So as I mentioned before, make sure you write it down correctly. The first time I saw this, I wrote down equals 2x, and I added that negative 4y to my other equation. So just make sure you write down the equations correctly. And this one, let's see, 4 times x plus y all over 7 equals 2x minus 4. So that's correct. Okay, good. And then on this one, we have x minus 2y over 2 all equals to 6, just 6. That's not so bad. And so the first thing I'm going to do, well, I'm gonna work out both of these, but the easier one is the right hand side. So I'm just going to do that first, and I'm going to multiply both sides by 2. So I get x minus 2y equals 6 times 2 is 12. And then on the right, as we saw in the previous problem, I'm going to put that over 1 and distribute that through, and that becomes 4x. So 4 times x is x. 4 times y is plus 4y all over, we still have the denominator of 7, equals 2x minus 4y. And then I have, I'm going to multiply both sides by 7. So the left side's not too bad, because when I multiply the whole side by 7, I get rid of the denominator, and that becomes 4x plus 4y. But it's important to remember that if I multiply the whole side by 7, the left side, I got to multiply the whole right side by 7. And you can't just say, well, I'm going to multiply this one thing by 7 and multiply this single thing. You got to do it by whole sides. But remember that you got to multiply the whole side by 7, because I have to now distribute that 7 through that side. So this becomes equals 7 times 2x is now 14x. 7 times negative 4y is minus 28y. If you just said, 7 times 2x is 14x, and then you just left it as minus 4y, you're going to do the whole problem. You're going to be wrong, even though most of your other math might be correct, and it's going to be it's aggravating. So be careful and distribute that 7 to the whole side. And now, well, on the right, real quick, I have a coefficient of 1, and that's what I look for, and this is the only one with a coefficient of 1. So I'm going to solve for x over here, and I just add 2y to each side, so x equals 2y plus 12, and you could say, well, that's 12 plus 2y, it doesn't matter which one, but now I want to plug this x, I have to plug it into our other equation, but before I do that, I have an x right here and an x right here, and I could absolutely plug my x equals this into both of those spots and it will work out. But I'm going to make life easier on myself, and I'm just going to subtract 4x from each side, and I get 4y equals 14x minus 4x is 10x minus 28y. And now I have two spots with y, and that doesn't really matter because I'm plugging in x equals. But I only have one spot with the x, and that makes my math a lot easier. So 4y, and so I'm going to plug that in now, equals 10. And then times, and then I plug in the 2y plus 12 minus 28y. And you can see that we have y in almost three different, well, not, we have it in three different spots, but it's only y, right? There's no x's, and so we have one equation, one unknown, we're good. So now I have to distribute that 10, so I have 4y equals 10 times 2y is 20y, and then 10 times 12 is plus 120 minus 28y. We simplify that side, we get 4y equals 20y minus 28y, that's negative 8y, plus 120, excuse me, plus 120. I'm going to move the negative 8y to the left, and I have 4 plus 8y, so 4y plus 8y is 12y equals 120. I divide each side by 12, and I get y equals 10. 120 divided by 12 is 10. That should be easy enough. So y equals 10, so that's great. And now I got to plug it into, again, either equation, but you know I have simply an x equals right up here, so I'm going to plug it into that equation. And that becomes x equals 2 times, and then y is 10 plus 12, and this is easy enough. Okay, so x equals 2 times 20 is 20, 2 times 10 is 20, plus 12. X is equal to 32. So my final answer is y equals 10, x equals 32. And that's the end of this section. I realize the videos are kind of long, but some of the problems were difficult. Hopefully you can do the other ones on your own, the odd ones. If not, please come into the tutoring center. Or if you have any questions on the problems that we did do, or perhaps you did them again in different ways and maybe you got stuck, please come into the tutoring center and see us. I'll see you later.